Everybody, in this video we are going to do a review. It's like a compilation of 20 different problems that have to do with a unit on solving linear inequalities. So we'll jump right in with number one. It says 3x plus 8 is less than or equal to 26, and then over here on the right it says which of these numbers would be solutions. So there's kind of two ways to go about this. You could just take each of these numbers and plug them in for x and simplify that left side and see if that number is less than or equal to 26, and if it is, then it's a solution. So that is one strategy. However, you could also solve by subtracting 8 from both sides. So we get 3x is less than or equal to 18. Then we can divide both sides by 3, and we get x is less than or equal to 6. So which means any of these numbers that are less than or equal to 6 would be solutions to that inequality. So if we look at our numbers, we have -3, yes, that will be a solution because that is less than or equal to 6. -7, also less than or equal to 6. 2 is less than or equal to 6. 1 is less than or equal to 6. However, 8, right, is not less than or equal to 6. Okay, so that's not going to be a solution. And 4 would be less than or equal to 6, so that one would be a solution as well. So those 5 numbers would be solutions to this inequality because when we plug them in for that variable, it makes the inequality true, right? That's what a solution of an inequality represents. Okay. Number 2 says solve and graph x minus 8 is less than 7. So to solve it, we just want to add 8 to both sides, and we end up with x is less than 15. So if we make our number line here, for ease of the video here, I'm just going to put 15 on my number line, and I'm going to put an open circle because it is less than, not less than or equal to. So we're not including 15 in the solution set here. And we would shade to the left because those values are less than 15. All right, number 2, solve and graph -14 is greater than or equal to 7x. Well, now to get x by itself, we need to divide both sides by 7. So -14 divided by 7 would be -2. That is greater than or equal to x. I like to write my variable on the left side, so I would say x is less than or equal to -2 would be my solution. So now if we graph that, we can draw our number line. Once again, I'm just going to put -2 on my number line here. Now this time it would be a closed circle because it is or equal to, which means we're including -2 in our solution set. And once again, we're less than, so we would shade to the left. All right. Next one, number 4, -4x is less than -24. Now we want to divide both sides by -4. And since we are working with an inequality, if we multiply or divide by a negative, we must flip the direction of the inequality symbol. So originally we had less than, now we have greater than. -24 divided by -4 would be +6. So we get x is greater than 6. Now it doesn't tell us to graph this one, but if you want to think through it, open circle on 6, shade to the right. All right. 5, 6, and 7, let's start here with number 5. It says solve and graph x divided by -5 plus 3 is less than or equal to 7. So I'm going to start off by subtracting 3 from both sides. So now we have x divided by -5 is less than or equal to 4. And now we can multiply both sides by -5. So there we go again, multiplying by a negative for an inequality. So we do have to reverse the sign of the inequality symbol, reverse the direction. So we end up with x is greater than or equal to -20. So if we want to draw that on a number line, we can put -20 here. We want greater than or equal to, so we're going to shade our circle or it will be filled. And we want greater than or equal to, so we're going to shade to the right. All right. Number 6, we have 8x plus 4 is greater than 3 times the quantity of 6 plus 2x. So I actually want to distribute that 3 on both sides to give us 8x plus 4 is greater than 18 plus 6x. Now we can solve. I'm going to subtract 6x from both sides. So that's going to give me 2x plus 4 is greater than 18. Now we can subtract 4 from both sides to get 2x is greater than 14. And then we divide both sides by 2 to get x is greater than 7. All right, so it doesn't tell us to graph this one, but once again, if we think about it, open circle on 7 and shading to the right. All right, number 7. We need to distribute on both sides here, so let's do that. So -3 times -4x would be +12x. -3 times 8 minus 24, greater than or equal. 2 times 6x would be 12x. 2 times 7 would be 14. and then we do have this plus 3 on the right side. So let's simplify that right side. 12x minus 24 is greater than or equal to 12x plus 17. But notice here we have the same linear term on both sides. We have a 12x on both sides. So when we go to subtract 12x to combine those like terms, they both cancel out. And what we're left with are two constants. So negative 24 is greater than or equal to 17. Well, is that true? Yeah, hopefully you're saying no, that's not true, right? So we would just draw a slash through that, and we would say that there is no solution to this inequality. All right, number 8, they just want us to write the inequality and then make a graph of it. So a number x is at least negative 7 and at most negative 2. So compound inequality here with the joining word of and. We can write these separately and then we'll write it as a single compound inequality. So at least negative 7. Well, at least is going to be greater than or equal to, right? So that's kind of like the minimum amount, at least. So greater than or equal to negative 7. And at most would be the opposite of that. Okay, so at most negative 2. So we put our word and here. All right, so now when we write this as a single compound inequality, we want to put our smaller number on the left, negative 7, our larger number on the right, negative 2. Variable goes in the middle, and now we fill in our inequality symbols. So x is less than or equal to negative 2. X is greater than or equal to negative 7. So that's what our inequality would look like. And then in terms of our graph on the number line, we would have negative 7 here, negative 2 would be somewhere over there. We're going to put closed circles on both of them, and then we would shade in the middle. Okay, closed circles because both of these were or equal to. Shading in the middle because an and is the intersection of the two inequalities. We're to the right or greater than negative 7, to the left or less than negative 2. All right. Number 9, we have 3x minus 4 is greater than negative 16 and less than 32. So we're just solving a single compound inequality. We want to add 4 to all three parts here. So now we get negative 16 plus 4 would be negative 12. We have 3x in the middle, and then 32 plus 4 would be 36. Now we can divide all parts by 3. So we get negative 4, we have x in the middle, and then we have 12. So our final answer would be x is greater than negative 4 and less than 12. So no graph needed on this one. All right, number 10, we have an or compound inequality. So we want to just solve this one. It doesn't look like we have to graph it, so we will just solve. So let's start on the left. Negative 3a minus 4 is greater than or equal to 8. So we can add 4 to both sides. That gives us negative 3a is greater than or equal to 12. Divide both sides by negative 3. So keep in mind we got to reverse the inequality symbol. So a would now become less than or equal to negative 4. Put a little box around that, write my or there. Now let's go and solve the one on the right. So 4a plus 3 is greater than or equal to 17. Let's subtract 3. So 4a is greater than or equal to 14. Now we can divide both sides by 4. And we're going to get a is greater than or equal to 14 over 4. So we could just write that as 7 over 2. All right. Okay. So now we see that. It doesn't tell us to graph it, but let's just sketch a quick little graph of that. So if we did that, we have, let's put negative 4 here. We know 7 over 2, that's like 3.5, right? 6 over 2 would be 3. So we have 1/2 left. So let's just call this 3.5. That's the same as 7 over 2, right? So now on negative 4, we would have a closed circle and we would shade to the left. And on 7/2 or 3.5, also a closed circle, but now this time we would shade to the right. Okay? So remember, that's what our or inequality should look like, rays going in opposite directions. We want a number that's either here or over here would be a solution to the compound inequality. All right. Okay, number 11. Now we're into an absolute value inequality. So remember, with absolute value inequalities, we want to make sure that absolute value is isolated first. So in this case, I would subtract 3 from both sides to get absolute value of x is less than or equal to 6. Now at this point, we can remember our acronym LAGO, which stands for if it's a less than symbol, then it's an and compound inequality. If it's a greater than symbol, then it's an or compound inequality. So in this case, we have less than or equal, so that's going to make it an and. So we know it's and and now we write our two inequalities. So now we're going to change it from an absolute value inequality to two separate or related linear inequalities. Same thing we did in the chapter about solving linear equations. When we solved absolute value equations, we change it from an absolute value equation to two related linear equations, and we solve it that way. So we're going to do the same thing here. One of our inequalities is going to look exactly like what we had in the absolute value form, so x is less than or equal to 6. The other one, we're going to keep what is inside the absolute value the same, but now we're going to reverse the inequality symbol, so less than or equal to becomes greater than or equal to, and we are going to change our 6 to the opposite, so 6 becomes negative 6. So now we have x is greater than or equal to negative 6, and x is less than or equal to 6. So now we want to write that as a single component inequality, so we would put our solution like this, right, which tells me that x is greater than or equal to negative 6, and it is less than or equal to positive 6. So if we were to graph this, which it asks us to do, negative 6 here, positive 6 there, both of these would be closed circles. We are greater than negative 6 while also being less than positive 6. So that's what our number line would look like. All right. Number 12, it says we earn 60 bonus points per star that we collect and a 100-point bonus for finishing the level in under 3 minutes. So we're playing some kind of game where we have to collect stars here. It says you need more than 1,000 points to advance to the next level. Write the inequality that represents how many stars you need to collect in order to advance. All right, well, we get 60 points per star, so let's call that 60s. We get a 100-point bonus if we finish under 3 minutes, so let's assume we're finishing under 3 minutes, so we're going to get that plus 100. So all of those points together needs to be more than 1,000, right? Greater than 1,000. So that's our inequality. Now we can solve for s to figure out exactly how many stars we have to collect to reach this goal. So let's subtract 100. So now we get 60s is greater than 900. We can divide both sides by 60. And 900 divided by 60, that's going to be 15. So we get s is greater than 15, which means we need to collect more than 15 stars to advance to the next level, right? So we see our original inequality there, and then we see our answer on the right. We need more than 15 stars. All right. Number 13, another word problem, says we like to collect coffee mugs. This is right up my alley. I love some coffee. I love coffee mugs too, right? It's kind of a way to commemorate a trip or a place you went. So kind of a cool question. You're collecting coffee mugs and your goal is to collect at least 75 mugs. But for whatever reason, space, I guess, you don't want to have more than 125, right? That's just an insane amount of mugs, right? Take up a lot of space. You already have 15 and your family of 5, so this includes yourself, you're going to all work together to collect these mugs. So it's kind of a family tradition, something that we've started apparently. So we want to figure out how many mugs each family member should collect to help us reach this goal. All right. So we know that we want to have at least 75. Okay. So 75 is like the minimum amount, right? We know we want to have a maximum of 125, so no more than that. We're starting off with 15 already, and we have a family of 5, right? So let's say that we have 5 family members. They're each going to collect some mugs, right? So 5 times m. We already have 15, so we can keep that in there. All right, now I'm going to add these inequality symbols in here because 5m plus 15 is representing how many mugs we're collecting, right? So now the 5 is because we have 5 family members. We're all going to collect some mugs. The 15 is the 15 mugs that already exist that we have in our possession. So we want 5m plus 15 to be greater than or equal to 75, right? We want at least 75, but we also want that to be less than or equal, or at most 125, all right? So that would be what it would look like, and now we can solve that by subtracting 15 from both sides, or from all sides, I guess we should say. So we get 60, and we have less than or equal, now we have 5m, and then this would become 105. Now we can divide here by 5. Okay, so we'll write our answer over here. So 12 looks to be our minimum per person, and 21 looks to be our maximum, right? So we had this inequality here to start with, compound inequality, and then, so now it looks like we know, okay, each family member needs to collect at least 12, right? Because we have 5 of us, 5 times 12 would be 60, and then we already have the 15. So there's the 75, right? That's the minimum. And then 21 times 5, that'd be 105, and then we have that 15 existing already, so that'd be 125, all right? So if everybody was going to collect the same amount, that would be what that inequality would look like. All right, number 14, we're going to graph and solve another absolute value inequality. Well, in this case, there's nothing happening to the absolute value, so we can go ahead and write our two inequalities. Remember log O, right? So this is a greater than or equal to, which means it's going to be an OR. One of our inequalities exactly as we see it. 2x minus 8 is greater than or equal to 4. The other one, let's keep 2x minus 8, but let's switch the inequality symbol, or let's reverse it. So greater than or equal to would become less than or equal to. And then the right side, or what's not inside the absolute value, needs to become opposite as well. So now we have two single inequalities joined with the word OR, so let's solve them separately, and then we can write our answer and graph it. So it looks like we're going to add 8, so we get 2x is less than or equal to 4, and we divide by 2, so we get x is less than or equal to 2. Over here, also add 8 and divide by 2. Okay, so we get x is greater than or equal to 6, or x is less than or equal to 2. So if we make our graph, it is an OR, so we should expect to have opposite rays. So let's put 2 here, let's put 6 here. Both of these are OR equal to, so that's going to be a closed circle. 6 we're greater than, so that's to the right. 2 we are less than, so that looks like it's to the left. All right, and that's how we do number 14. All right, 15, another absolute value inequality. This time it's less than though. So remember log O, less than is and. So one of them exactly as we see it. So 4x minus 12 is less than 8. The other one, let's keep 4x minus 12. Let's change less than to greater than, and then 8 would become negative 8. Right? That's just how we set it up in order for us to solve. So now it appears we need to add 12 to both sides. So we get 4x is greater than 4. Divide by 4, so x is greater than 1. And here let's add 12. So 4x is less than 20. We divide by 4, and x is less than 5. Okay? So now let's write that as a single compound inequality. So we would put 1 here, x in the middle, 5 on the right, and we are less than 5 and we are greater than 1. So that is what our single compound inequality would look like. All right, number 16. We have a greater than or equal to, so we know that for greater than or equal to, log O tells me it's going to be an OR. But before we write our two inequalities, before we make the right side opposite, anything like that, we need to undo what's happening to our absolute value. So first we're going to add 2. So now we have 3 times the absolute value of x minus 5 is greater than or equal to 12. Now we want to divide everything by 3. So now we get absolute value of x minus 5 is greater than or equal to 4. Now at this point, our absolute value is all alone. It's isolated. Let's write our two related linear inequalities. So remember it's an OR. We'll come over here. One of them is exactly as we see it. X minus 5 is greater than or equal to 4. The other one, we keep what's inside the absolute value, but we reverse the sign and we make the other side of the inequality opposite. So x minus 4 would be less than or equal, or x minus 5 would be less than or equal to negative 4. Now we can simplify these by adding 5. So we get x is less than or equal to 1, or add 5 again, x is greater than or equal to 9. And that would be our inequality right there. It doesn't tell us to graph it, so we won't do that. So we have less than or equal to negative 1, greater than or equal to negative 9, less than or equal to 1, greater than or equal to 9. So those do appear like they would be rays going in opposite directions. So all looks good for 16. All right, number 17, it says the following prices. They are prices of a new computer monitor. We're willing to pay the mean price with an absolute deviation of at most 30. Let's write the inequalities. So mean means average. So it looks like we have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8 values, right? So I did this earlier off screen, but if we add these together, we get 2,200. So it'd be 2,200, and then we're going to divide that by 8 because that's how many numbers we had. And it looks like our average, or the mean price, is $275, okay? So remember, for absolute deviation, we have this equation that says the absolute value of x minus the given value is equal to the absolute deviation. So now in this case, the given value would be the mean price. So we can write x minus 275. But now for our deviation, it says at most 30. So not equals 30, but less than or equal to 30. Okay, so that would be what our absolute value inequality would look like. But now we can actually solve that because we know we could write that as a compound inequality. So let's do that. All right, so it is a less than or equal. So less than means and, right? So we're going to say that x minus 275 is less than or equal to 30, and x minus 275 is greater than or equal to negative 30, right? So we could actually set it up like that already in the form of a compound inequality or a single compound inequality. Now we can solve this by adding 275 to both sides. And we're going to get now our range of prices that we're willing to pay. So negative 30 plus 275 would be 245. And 30 plus 275 would be 305. Okay? So now look what we have. We kind of have our price range, right? Anything that's less than $245, we're not going to buy it. So for whatever reason, right, we just want to make sure we get something that at least is of good value. But then also we're not going to buy anything that's more than $305. So we don't want to spend too much, but we want to spend enough so that we're getting something of value. So now we could look at that and go back and say, okay, would we buy the $200 computer? No, or the monitor? No, it's too cheap. 250, 260, 270, 280, 290, all those are good. 320, 330, those are a little too expensive for what we want, so we would not buy those. All right, so that's kind of what we mean by the absolute deviation. How much are you willing to budge either way of a set value? So in this case, the set value or the given value was the mean. So the average price was $275. Looks like we're willing to spend $30 less than that or $30 more than that. That's what absolute deviation represents. All right, number 18, they want us to just write the inequality and then graph it. So a number x is no more than, so x is less than or equal to negative 2, or x is no less than, so greater than or equal to 8. So that's what it would look like. It is an or, so we can actually just leave it like that. And now we can draw our graph. Okay, so let's put negative 2 here, let's put 8 over here. It appears both of these would be filled or closed circles because it's or equal to. And we are less than negative 2, which means we go to the left. We are greater than 8, which means we go to the right. And that's what our graph would look like. All right, number 19 says write this as an inequality. 5 times a number t minus 7 is no fewer than 18. So it doesn't tell us to solve it or anything, so we don't have to solve for t. We just want to write it as we see it. So 5 times a number t would be 5t minus 7, so subtract 7, is no fewer than 18. So no fewer than, which means 18 is the minimum, right? So this needs to be greater than or equal to 18, okay? All right, and our last one, number 20, we are given a number line, we're given an inequality that's been graphed, and they just want us to write the inequality that's being represented. So notice where our dot is. It's on negative 1. Also, they didn't give us a variable, so let's just use x. When negative 1 is where our dot is located, our circle, it is open, which means it's not or equal to, and it's going to the left or less than negative 1. So that's what it would be. X is less than negative 1. Okay, so that is the review for a unit, a typical Algebra 1 unit on solving linear inequalities. I hope this helps. I hope this helps to prepare for possibly an upcoming test or just to review the content as you progress through your Algebra 1 course this year. Thanks for watching.